In certain situations, electrical authorities having jurisdiction may permit electricians to leave existing junction boxes unbonded to a newly installed main panel. This allowance is often based on several factors. Firstly, the circuit conductors that supply the existing junction box are often already connected to the grounding conductor within the new main panel. Consequently, the junction box achieves indirect bonding through these conductors. Secondly, many older fuse boxes incorporate the main disconnecting means within the enclosure itself. Bonding the enclosure to the new panel would establish a direct interconnection between the neutral conductor and the grounding conductor at the disconnecting means, which is generally prohibited. Additional considerations influence the decision to bond or not to bond an existing junction box. If the wiring method within the existing junction box is non-metallic, such as non-metallic sheathed cable, bonding of the enclosure may not be required. The location of the existing junction box is also a factor. If the junction box is situated in a dry location and is not readily accessible to the public, bonding may also be deemed unnecessary. The specific code requirements for bonding junction boxes can vary depending on the local jurisdiction. Electricians should always consult local codes and seek guidance from the authority having jurisdiction. While authorities having jurisdiction may allow unbonded junction boxes in some instances, adhering to best practices suggests bonding junction boxes to the main panel whenever feasible. This promotes proper grounding and safety. The reasons for allowing unbonded junction boxes can be summarized as follows. 1. Circuit wires are already bonded, meaning the circuit conductors that feed the old junction box are typically bonded to the ground wire in the new main panel, therefore the junction box is indirectly bonded through these wires. 2. Fuse box disconnect switch. In many older fuse boxes, the main disconnect switch is located inside the box. Bonding the box to the new panel would create a direct connection between the neutral and ground wires at the disconnect switch, which is not allowed. Other factors that influence the decision to bond or not bond an old junction box include 1. Type of wiring. If the wiring in the old junction box is non-metallic, for example, non-metallic sheathed cable, bonding may not be necessary. 2. Location of junction box. If the junction box is located in a dry area and is not accessible to the public, bonding may also not be required. 3. Codes and standards. The specific code requirements for bonding junction boxes vary depending on the local jurisdiction. Electricians should always refer to their local codes and consult with the authority having jurisdiction for guidance. It is generally considered best practice to bond junction boxes to the main panel whenever possible to ensure proper grounding and safety. To elaborate further on the best practices, it is important to understand the role of grounding and bonding in electrical systems. Grounding refers to connecting the electrical system to the earth, while bonding involves connecting metallic parts of the electrical system to create a low impedance path for fault current. Bonding ensures that if a fault occurs, the fault current can quickly return to the source, tripping the circuit breaker or blowing the fuse and preventing electrical shock hazards. When a new main panel is installed in an older home, the existing wiring may not meet current code requirements. This is especially true for the grounding and bonding systems. In some cases, the existing wiring may not have a dedicated grounding conductor, or the grounding conductor may be undersized. If the existing junction box is not bonded to the new main panel, it may not be properly grounded, which can create a safety hazard. Bonding the junction box to the new main panel ensures that it is properly grounded and that fault current can quickly return to the source. This reduces the risk of electrical shock and fire. There are several ways to bond a junction box to the main panel. One common method is to run a bonding jumper from the junction box to the grounding electrode conductor at the main panel. The bonding jumper should be sized according to the requirements of the National Electrical Code, often referred to as NEC. Another method is to connect the junction box to the equipment grounding conductor in the circuit that feeds the junction box. The equipment grounding conductor should be properly sized and connected to the grounding bus at the main panel. When working on electrical systems in older homes, it is important to be aware of the potential hazards and to take appropriate safety precautions. This includes wearing personal protective equipment such as gloves and safety glasses, and using properly insulated tools. It is also important to de-energize the circuit before working on it and to verify that the circuit is de-energized using a voltage tester. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. A qualified electrician has the training and experience to safely and properly install and maintain electrical systems. They can also help you to ensure that your electrical system meets current code requirements. In addition to bonding junction boxes, there are other important considerations when upgrading the electrical system in an older home. These include ensuring that the wiring is properly sized for the load, that the circuit breakers are properly rated, and that the electrical panel has sufficient capacity. It is also important to inspect the existing wiring for damage or deterioration and to replace any damaged or deteriorated wiring. Upgrading the electrical system in an older home can be a complex and challenging project. It is important to plan the project carefully and to follow all applicable codes and regulations. By taking the time to do the job right, you can ensure the safety and reliability of your electrical system for years to come. Additionally, when dealing with older electrical systems, it's crucial to consider the presence of potentially hazardous materials such as asbestos. Asbestos was commonly used in older homes for insulation around wiring and electrical components. Disturbing asbestos-containing materials can release fibers into the air, posing a health risk. Before undertaking any electrical work in an older home, it's recommended to have the area inspected for asbestos and, if found, to have it properly removed by a qualified professional. Another important aspect is the proper identification of wiring. In older homes, the color coding of wires may not conform to current standards, making it difficult to determine the function of each wire. It's essential to use a voltage tester and wire tracer to accurately identify each wire before making any connections. This helps prevent accidental shorts or miswiring, which can lead to electrical hazards. Furthermore, the condition of the insulation on older wiring should be carefully inspected. Over time, insulation can become brittle and cracked, exposing the conductors and increasing the risk of electrical shock. If the insulation is damaged, the wiring should be replaced with new wiring that meets current safety standards. When replacing wiring, it's important to use the correct type and size of wire for the intended application. The National Electrical Code specifies the minimum wire size for various circuit types and ampacities. Using undersized wire can overload the circuit and create a fire hazard. In addition to wire size, the type of insulation is also important. Different types of insulation are designed for different environments and applications. For example, some types of insulation are more resistant to heat and moisture than others. It's crucial to select the appropriate type of insulation for the specific application to ensure long-term reliability and safety. Another key consideration is the proper grounding of electrical equipment. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. In older homes, the grounding system may not be adequate or may be missing altogether. It's essential to ensure that all electrical equipment is properly grounded according to current code requirements. This may involve installing new grounding electrodes, running grounding wires to metallic enclosures, and bonding metallic water pipes and gas pipes to the grounding system. Surge protection is another important aspect of electrical safety. Surges can damage sensitive electronic equipment and even cause fires. Surge protection devices, also known as surge suppressors, can help to protect against surges by diverting excess voltage to ground. It's recommended to install surge protection at the main electrical panel and at individual outlets where sensitive electronic equipment is used. Arc fault circuit interrupters, also known as arc fault circuit breakers, are another important safety device. Arc faults are a common cause of electrical fires. Arc fault circuit interrupters can detect arc faults and trip the circuit breaker, preventing a fire from starting. The National Electrical Code requires arc fault circuit interrupters in many circuits in new construction and renovations. Finally, it's important to remember that electrical work can be dangerous. If you are not comfortable working on electrical systems, it's best to hire a qualified electrician. A qualified electrician has the training, experience, and tools to safely and properly install and maintain electrical systems. They can also help you to ensure that your electrical system meets current code requirements and is safe for you and your family. Regular maintenance is also important for ensuring the safety and reliability of your electrical system. This includes periodically inspecting the wiring, circuit breakers, outlets, and switches for damage or deterioration. It also includes testing the ground fault circuit interrupters, also referred to as ground fault circuit breakers, to ensure that they are working properly. If you notice any problems with your electrical system, it's important to have them repaired promptly by a qualified electrician. Ignoring electrical problems can lead to more serious issues such as electrical shock, fire, and equipment damage. When upgrading an electrical panel, consider the future needs of the home. As technology advances, the demand for electricity is likely to increase. Installing a panel with sufficient capacity can prevent overloads and ensure that the electrical system can handle future power demand. The NEC provides guidelines for calculating the electrical load of a home and determining the appropriate panel size. In addition to the panel size, the type of panel is also important. There are two main types of electrical panels: breaker panels and fuse panels. Breaker panels are more common in modern homes because they are easier to use and maintain. Fuse panels require replacing fuses when they blow, while breaker panels simply require resetting the breaker. When upgrading from a fuse panel to a breaker panel, it's important to ensure that the new panel is compatible with the existing wiring. In some cases, it may be necessary to replace the wiring to accommodate the new panel. Another consideration when upgrading an electrical panel is the location of the panel. The panel should be located in a dry, accessible area. It should also be protected from physical damage. The NEC specifies the minimum clearances around electrical panels to ensure that they are accessible for maintenance and repairs. The grounding electrode system is a critical part of the electrical system. The grounding electrode system provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The grounding electrode system typically consists of a ground rod, a ground plate, or a metallic water pipe that is connected to the earth. The NEC specifies the requirements for grounding electrode systems, including the size and type of grounding electrodes and the methods for connecting them to the electrical system. Bonding is another important aspect of electrical safety. Bonding involves connecting metallic parts of the electrical system to create a low impedance path for fault current. Bonding ensures that if a fault occurs, the fault current can quickly return to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. The NEC specifies the requirements for bonding, including the types of bonding conductors, the methods for connecting them, and the locations where bonding is required. When working with electrical systems, it's important to use the right tools. This includes insulated screwdrivers, pliers, wire strippers, and voltage testers. Using the wrong tools can damage the electrical system or create a safety hazard. It's also important to wear personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical shock and other hazards. Electrical codes and standards are constantly evolving to improve safety and reliability. It's important to stay up to date on the latest codes and standards and to follow them when working on electrical systems. The NEC is the most widely used electrical code in the United States. It is updated every 3 years to reflect changes in technology and best practices. Local jurisdictions may also have their own electrical codes that are based on the NEC but may have additional requirements. Consulting with a qualified electrician is always a good idea before undertaking any electrical work. A qualified electrician can help you to plan the project, select the right materials, and ensure that the work is done safely and properly. They can also help you to navigate the complex world of electrical codes and standards and to ensure that your electrical system meets all applicable requirements. Furthermore, when upgrading the electrical system in an older home, it's crucial to assess the existing wiring for any signs of deterioration or damage. This includes checking for cracked or brittle insulation, loose connections, and corroded terminals. If any of these issues are present, the affected wiring should be replaced to ensure safety and prevent future problems. Another important consideration is the presence of aluminum wiring. Aluminum wiring was used in some homes built in the 1960s and 1970s. Aluminum wiring can be a fire hazard if it is not properly installed and maintained. If your home has aluminum wiring, it's important to have it inspected by a qualified electrician and to take steps to mitigate the risks. This may involve replacing the aluminum wiring with copper wiring or installing special connectors that are designed for use with aluminum wiring. When working with electrical systems, it's essential to follow safe work practices at all times. This includes energizing the circuit before working on it, using properly insulated tools, and wearing personal protective equipment. It's also important to be aware of the potential hazards such as electrical shock, arc flash, and explosions. By following safe work practices, you can minimize the risk of injury and ensure that the work is done safely. The National Electrical Manufacturers Association, or NEMA, provides standards for electrical enclosures. These standards specify the level of protection that the enclosure provides against environmental factors such as water, dust, and corrosion. When selecting an enclosure for electrical equipment, it's important to choose one that is appropriate for the environment in which it will be used. The Underwriters Laboratories, or UL, is an independent organization that tests and certifies electrical products. UL listing indicates that a product has been tested and meets UL safety standards. When purchasing electrical equipment, it's important to look for the UL listing mark to ensure that the product is safe and reliable. In addition to the technical aspects of electrical work, it's also important to consider the aesthetic aspects. Electrical installations should be neat and organized. Wires should be properly supported and routed. Electrical boxes should be flush with the wall or ceiling. By paying attention to the details, you can create an electrical installation that is both safe and visually appealing. Finally, it's important to document all electrical work that is performed. This includes creating a wiring diagram, labeling circuits, and keeping records of inspections and repairs. Proper documentation can make it easier to troubleshoot problems in the future and can also be helpful when selling the home.